Hi, let's talk about Virginia's climate. First, let's look at Virginia on a map. You can see here that it's on the eastern coast of the United States, and going from north to south, it's in the middle. Also, we have five distinct geographic regions of Virginia. First, we have the Appalachian Plateau, which is an elevated region of flat land in the west of the state. Then we have these two mountainous regions. We have a hilly region called the Piedmont, and we have the coastal plain or tidewater region, which is a low elevation region next to the Atlantic Ocean, as you can see in this map from Virginia history. Next, here are some pictures of the landscapes that can be found in Virginia. And then let's look at some temperature maps from the Midwestern Regional Climate Center. First, we can look at the annual map, and this shows us that the average temperature in Virginia is usually around 50 to 60 degrees Fahrenheit. We can look at the January average temperatures, and the temperatures during that time of the year are about 30 to 40 degrees Fahrenheit. And in the hottest month of the year, they're 70 to 80 degrees Fahrenheit. Now, what influences the temperature patterns that you can see in the maps? First, we have Virginia's latitude. So we know that as we get closer to the equator, it gets warmer because the sun shines more directly on the equator. Then we also have the Atlantic Ocean to the east of the state, and bodies of water don't change their temperature easily, so that makes the climate in Virginia more moderate because that body of water is influencing its temperature changes. Then also, the Atlantic Ocean is very warm in this eastern part of the United States because its currents bring warm water up from the equator northward to where these eastern states are. So that makes Virginia's climate warm also. Then we also have a this western part of Virginia has mountains, and that is going to be colder because of the higher elevation. Now, if we look at the precipitation maps, they the precipitation map over here resembles a temperature map, and that's because in the warmer regions, more water is going to evaporate, and that evaporated water will form clouds, which will produce precipitation. In addition, warmer air rises. So when the warm air rises, it carries up the water vapor with it and forms clouds. Cold air does the opposite, it sinks, so it does not form those clouds. Now, if we also look, the Atlantic Ocean is again to the eastern part of the state, and some of the moisture from the Atlantic Ocean can be transferred onto the land, over the land, and can also produce precipitation. If we look at the snowfall map, we can see that there's more snowfall in the north and in the west where those mountains are, and that makes sense because colder regions are going to have more snow. Now let's look at some Köppen-Geiger classifications of Virginia. Köppen-Geiger classification is one of the common classification methods for climate. You can see that most of Virginia is either CFA or CFB. The first letter C means that Virginia is a subtropical climate, and subtropical climates are moderately warm. The second letter is an F. That means fully humid. And what that means is that the precipitation is distributed throughout the year. There's not a lot of precipitation concentrated in one season. And then we have our last letter, CFA or CFB, and that last letter is an indication of temperature. So CFA climates are warmer than CFB climates. CFB climates are warmer than CFC climates. Of course, we don't have CFC climates on this map, but they would be colder than CFB climates. And then we can also see the small part of land here that's DFA. So that D means a continental climate. Continental climates are colder, and they will have snowy winters. They're going to be located to the interior of continents. Now let's look at some regression analysis of Virginia's climate. I've obtained data from the National Oceanic and Atmospheric Administration and have calculated the average rate of change for Virginia's temperature and precipitation since 1895. And what I found is that Virginia's temperature has been increasing at a rate of 0.007 degrees Celsius per year. Now, if we multiply that by the number of years there have been since 1895, we get about zero point 0.9 degrees Celsius, which is more than 1.5 degrees Fahrenheit. Now, a, a change of 1.5 degrees Fahrenheit in Virginia is significant. We know that Virginia's climate is warming with the rest of the world. We can also compare the rate of change of Virginia's temperature with other global rates of change of temperature. So we can see that Virginia's rate of change of temperature is closest to the rate of change of temperature of the ocean in the northern hemisphere, which makes sense because Virginia is next to the ocean. Now we can also look at how the precipitation is changing, and Virginia is getting wetter at a rate of about 0.03 inches per year. Next, we have some pictures of the species existing in Virginia. So here's some of the biodiversity in the Appalachian forests of Virginia. So over here you can see some deciduous trees, and over here we have a ruffed grouse, which is a ground-dwelling bird, and here we have some mussels which live in the rivers that are in these forests. Next, we can look at the wildlife in the coastal region. So here is a bay scallop, and here are some seabird chicks. These are plovers. And here is some eelgrass, which is a type of seagrass, as you can see in these pictures from nature.org. And finally, here are my sources. Thank you for listening.